Hi, I'm Tom.
I'm John.
I'm Ryan.
And I'm Brian.
And
we're Group J.
And this is our AEV design project.
This video outlines the design process and the steps used to achieve the goals outlined in the mission concept review.
The individual design stage was a crucial part of the team's design process. It offered several ideas used for the final design, such as the vertical hang design as a base and turning propellers. These were deemed to be good concepts for the team moving forward, as it provided an almost exact center of mass while allowing the motors to be in push the entire way. The pusher design was thought of before the wind tunnel lab was experimented. While the individual designs were an important concept, the team's brainstorming session actually produced the ideas and overall final design concept on Lab 1. The inspiration behind the idea was given to us from the theme itself, Star Wars. The Slave One offered great concept being upright and rotated wings. It ultimately looked cool when the AEV was compared and was decided to be the final design. The wings holding the motor and propellers also faced changes. The original Gerding design offered the style we were looking for, but no way of attaching it to the servo motor. These problems were solved by adding a groove built into the wing, allowing the servo to turn the wings. The new wing also had a width addition to allow the new part to fit. The base part went through the most changes to its design. From the basic flat laser cut part, it had several challenges attached to it that the team had to face. Upgrades to the height had to be implemented so that the propellers could function properly without hitting the rail. Configurations for holding the battery and Arduino were also added to improve weight and center of mass.
After much trial and error, our final AEV design shows all of the improvements and innovations made during the project. This design shows the best of what Team J has to show in terms of consistency, performance, and creativity. The focus of our design is the motor arm, named such as it allows both brushed motors to rotate 180 degrees with a single servo motor. This final red design shows the improvements made on previous versions with its perfect fit and finish. As this vehicle is vertically oriented, it became apparent that any weight shifted to the right or left of the center of the vehicle would cause the AEV to be off balance and swing more during turns. Shifting the Arduino and battery to be more underneath the pulleys kept this vehicle stable. In addition, several pieces were added to allow for convenient tests and maintenance. Secure points for managing cables helped to keep the AEV organized, stylish, and manageable. Some material was removed from the design, as experience with plastics showed that most of the material was unnecessary for the structural integrity of the AEV. This allowed for the AEV's body to be much more lightweight and therefore more efficient. All of these features were combined into a single 3D printed piece to allow for more complex shapes and to create a more unified AEV design.
This group successfully collaborated in designing an efficient and practical advanced energy vehicle while also completing the objectives with innovative designs while sticking to the course theme.